Hello everyone. Welcome back to my YouTube channel. If you're new here, hit the subscription button to get notified whenever I post important tutorial like this. Today, let's talk about very important topic, delta and star windings comparisons. It is important to note that the winding processes are the same, but the difference is in the terminal connections after the winding processes, and this is what classify them delta or star winding. Before I proceed, note that delta winding can be called mesh winding, and star winding also called the Y winding, because of their shapes. Delta and star windings are two common configurations used in three-phase electrical systems, particularly in transformers and electric motors. Let's quickly go into details. Here are some key comparisons between delta and star windings. 1. Configuration. In delta winding configuration, the three windings are connected, end to end in a loop, forming a triangular shape. But in star configuration, the three windings have one end connected together at a common point, which is the neutral point, while the other ends are connected to the supply lines. 2. Voltage in each winding. In delta winding, line voltage is equal to phase voltage. But in star winding, line voltage is square root 3 times the phase voltage. 3. Current in each winding. In delta configuration, line current is square root 3 times the phase current. But in star configuration, line current is equal to phase current. 4. Phase shift. In delta winding, there is no phase shift between line and phase voltage or current, all are in phase. But in star winding, the phase currents are 120 degrees apart, and the line currents are also 120 degrees apart. 5. Harmonics. In delta configuration, generally has lower harmonics, which can lead to less distortion in the current waveform. But in star configuration, can accumulate more harmonic distortion, especially if a neutral is used with unbalanced loads. 6. Neutral point. In delta configuration, there is no neutral point exists, it cannot carry unbalanced loads. But in star configuration, a neutral point is available and can be used for grounding or carrying return currents in case of unbalanced loads. 7. Starting characteristics. In delta winding, it is better for starting high-torque motors as it provides high starting current, but in star winding, typically used for reducing starting current, star-delta starters are used to prevent inrush current. 8. Applications. In delta configuration, it is commonly used in high-power motors and equipment where full voltage is required, such as industrial applications. But in star windings, it is frequently used in transformers, generators, and motors that operate under variable loads or require neutral grounding. 8. Efficiency. In delta configuration, it usually provides higher efficiency for machines needing robust performance. But in star configuration, it generally offers better voltage regulation at lower loads, although it may be less efficient under heavy load conditions. 9. Voltage regulation. In delta winding, it has good voltage regulation, typically higher voltage regulation, making it suitable for high power applications. But in star configuration, it is better for voltage stabilization under varying loads. Lastly, protection. In delta configuration, it is less sensitive to phase failure, as other phases can still maintain functionality. But in star configuration, it can be more vulnerable to phase-to-phase faults, requiring additional protection mechanisms. Summary. Choosing between delta and star winding configurations depends on the specific application requirements, such as the need for neutral points, the starting characteristics of motors, and efficiency considerations. Each configuration has unique advantages and limitations that should be taken into account when designing or selecting electrical systems. If this video is helpful to you, kindly like and subscribe to my YouTube channel to support the channel. Thank you for watching. Bye for now.